All right, we're talking about transformations of functions. What's transformation mean? To transform, like to move or change, right? They think about like a transformer, right? Like they change into other things, right? Transformers, okay? So that's what we're going to do with these graphs, okay? It's not as exciting as a transformer, but we're going to move and change these graphs, okay? Sometimes they're moving left and right. Sometimes they're moving up and down. Sometimes we're going to compress them. Sometimes we're going to stretch them. But we're going to do things to the graph to make them look a little bit different, okay? So these are the learning goals here. This is something I actually want you to scan through here. I don't always spend a lot of time on this slide, but these are things that we want to be able to do after this lesson. Okay, so by looking at either a graph or an equation, we want to be able to recognize which function it is, okay, whether it's being shifted vertically, whether it's being shifted horizontally, whether it's being reflected, okay, and then we want to be able to graph a sequence of functions too. Okay, so these are things like, this is our takeaway today, things we want to be able to do. All right, so these are some frequently encountered functions, okay? I wouldn't write them in your notebook like this, but I do want you to write down these 7 functions, okay? You don't have to write down the introductory sentence, okay? You're going to be fine. Okay, that's f of x equals c. We'll talk about what all these mean in a little bit here. But that's f of x equals c, f of x equals x. Then we have an absolute value function. We have a quadratic function. What we want to be able to do here is be able to look at these and say, all right, that's a blank function, the type of function, and the graph is going to look like blank, okay? So, for example, when we see, this one's the easiest one to recognize, I think, because it has those bars, right? Okay, that's an absolute value function. So right away, boom, it's an absolute value function. I know the shape of that graph is going to be a V, okay? V for value, absolute value. What shape is a V? A V, right? So an absolute value function, the graph is going to be a V, all right? We also have the quadratic function, okay, which is with an exponent of 2. That's going to be that parabola that we've talked about before, the U shape, okay? Then we have these different ones. We'll talk about what they look. But we want to be able to recognize, all right, that's a cubed root function, or that's a square root function. The graph should look like blank, okay? So we're going to start with f of x equals c, okay? And if you, however you want to note this in your notes, if you want to just draw an arrow to what you just wrote, or if you want to rewrite it, you need to know that f of x equals c is a constant function, okay? And then I would sketch what that looks like. That's going to be just a horizontal line. The domain of this is negative infinity and infinity because it's going in both directions. The range is c. So whatever c is your y-intercept. Then that's your range because it can't go any higher than that, can't go any lower than that. And then this function is even because it would be symmetrical across the y-axis. Next one. All right, this is the identity function. Okay, remember that f of x is just y, right? So what this really is y equals x. So if x is 1, y is 2. If x is 2, y is 2. If x is 3, y is 3, right? Okay, so that's just the identity function. It goes up 1 over 1, up 1 over 1, up 1 over 1. Okay, the domain of this one is negative infinity, infinity. The range is the same. And this is odd because we could rotate it and have the same thing. All right, the next one is our absolute value function that we talked about. So f of x equals the absolute value of x. Okay, it is the absolute value function. Make sure that you know the shape of these, okay? This is even because it would be reflected across, or symmetrical across the y-axis. That's one of our takeaways today, is we want to be able to recognize the shape. Just walking around and I'm seeing some notebooks, and so far we haven't sketched all the graphs, and I know the first two were pretty simple, but make sure you're copying that down. It doesn't have to be anything fancy. Just something like that, it's fine, so that you know that it's the shape of a V. Okay, next one is our quadratic. So f of x equals x squared. Domain, range, and it is even. And then there's that U shape. Sometimes, remember, with that, with the transformation, sometimes the U or the V, in the case of the absolute value, it might be shorter and fatter, it might be taller and skinnier, but it's still a V, or in this case, with the quadratic function, it's a U shape. But for this one, the parent function, we're talking about x squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, and it starts to increase exponentially. Square root function. So f of x is the square root of x. It's our square root function. Domain, it cannot go past 0. Notice we have a bracket there, okay, because we don't have any real numbers. If we have negative x, square root of negative 2, like we can't do that with real numbers. We know we can do it with imaginary numbers, but not with real numbers. So the domain is from 0 to infinity. Our range, same thing. Okay, and then this is neither odd nor even. I call this it's like a swoop, like somebody's hair. Like if you go like if Ben goes like swoop with his hair, it's like the absolute value function. Or not absolute values function, sorry, the square root. All right, next one is our cubic function. So this is x cubed, hence cubic function. Domain, range are unlimited, and then this is odd, because we could rotate it. All right. Now this is a cube root function. This is different. Domain, range, odd. Notice with this one, the graph, just on the even, the positive side, looks similar to our square root graph. Right, we have that swoop and that top right quadrant, but we also have one on the bottom left, right? That's because when we're doing the cube root function, now we can have those negatives. Okay, so for example, if we have the cube root of negative 27, we can do that. Okay, the cube root of negative 8, we can do that. It's negative 2, right? So now, because it's cubed and we have an odd index, we can do that now with a real number. I think this one looks like a wave, like coming into the shore. Okay, so there are some different things that we can do to this, okay? So the first thing I want you to write in your notes is just this. This is our general form. So we're going to write f of x equals a parentheses x minus h plus k. This is our general form. And in this case, we just have it in parentheses. in this way right here, this is actually just linear, okay? This would be y equals m. The m would be your a. Okay, x would be what's in the parentheses plus b. That's how high we move it, okay? K goes up and down, okay? But this is just the general form. So sometimes, and you don't have to write all of these down, but sometimes we'll have this general form, but then there'll be a 2 right here. So what form would that be?
2.
That's going to be a quadratic because we have a power of 2, right? So this shape you know now is going to be a U, okay? And then whatever the A, H, and K are is how we're going to move it, all right? Sometimes it could be a graph like this. What would this be? That's absolute value. But it's the same form, right? Okay, Alyssa, what shape would this be? You just did it. A V, yeah. Okay, this would be a V. All right. We could also have it as a times the square root. So this would be that swoop that we were talking about. So it's still that general form. We could have it as the cube root. But do you see how that general form can fit into any of these? Okay, we can apply that A, X, H, K to any of these, okay? So that's what we're going to start working towards now. And we're going to start defining what these things mean. These are some of our biggest takeaways today, okay? We just laid the foundation with what our images should look like, what our graph should look like. Now, this is some of the important stuff, like really important stuff. So f of, if it's x minus h, okay, so if in that general form we have x minus h, it's going to move right. If it's x plus h, it moves left. That's a big takeaway, is that our h moves opposite the sign. So if we had a graph or an equation that was f of x equals, and then in parentheses, we'll just do x minus 4. Okay, would that move to the left 4 or to the right 4?
Right.
Yeah, so it's going to be translated right 4. Okay, if it was f of x equals x plus 4, which way is that going? To the left. So it's opposite. And there's a reason behind that. The reason behind that is because we need the parent function. Like if we were to put that in and get zeros, it'd be on the origin and all this. But you just need to know this part right here, that h moves opposite the sign. So if it's plus h, it's actually going left. If it's minus h, it's actually going right. Okay? Now our k is pretty simple. Okay? That one sticks to our like kind of default. Okay? A positive k moves it up. Negative k moves it down. Which if you think about our slope-intercept form, if we had a positive b, right, a positive y-intercept, it moved it up, right? Okay, if we had a negative, it moved down, same thing. It's the same concept. Okay, next part, we're talking about reflections, okay? So if we have negative f of x, okay? I really think with what we're using for our form, this should really be more of like an A, okay? So if that A is negative, it's going to reflect over the x-axis, okay? I think just leaving it as an F, I think, could end up confusing you guys because of where we think about that. So if the A is negative, it's going to reflect over the x-axis. If our A is positive, but we have a negative inside, whatever it is, then it's going to be reflected over the y-axis, okay? So I'm going to use a square root graph here to show you what I mean here. So I'm going to use different colors. So black is going to be just our parent function. It's what we just talked about. So the parent function of our square root. So f of x equals the square root of x. That's just going to be that swoop, right? Up to the right. So it's going to look like this. Right? That's our parent function. Okay? If I say f of x equals negative square root of x, that's going to flip it across the y-axis. Okay? So now that's going to be the same thing. It's just going to be reflected down here, like that. Does that make sense? Because it's going to take whatever I put into the function and turn it negative. All right? Then if I have it as f of x equals the square root of negative x, like this, it's going to reflect it across the y-axis. So it's going to be right here. Making sense so far, where that negative is? All right, and then lastly, if I had it in both places, if I have f of x equals the negative square root of negative x, it would be down here. Okay, so that's just a visual example of what we're talking about, but knowing what the negative does, how the negative and where it is affects the graph is really important. Okay, so now we're going to talk about A. Okay, so that's where that A is. So I'm going to erase this because I don't really like how that's showing up. So remember, we have f of x equals a times x minus h plus k, right? Not b, plus k. So if this A is 1, or is greater than 1, if the absolute value is greater than 1, we're going to have a vertical stretch, is what you're going to hear me say. A vertical stretch. That just means our y values are growing faster, are getting bigger faster. So it's going to be a vertical stretch. Okay? Right now, we don't really care about the positive negative because we already know what that does. So that's why it has that absolute value symbol. So if the absolute value is greater than 1, so if your number is positive 2, positive 3, negative 4, negative 2, any number bigger than 1, okay, it's going to have a vertical stretch. If it's between 0 and 1, that means it's a fractional part. So we have a fraction in the place of A, or a decimal in the place of A, like 1/2, or 1/3, or 0.75. That means it's going to be a vertical compression, or a shrink. That means that our y values are increasing at a slower rate. So the graph is going to be shorter and fatter. Okay, so if we think about absolute value graphs, look at my hands here. Okay, our normal graph is like this, right? Okay, a vertical stretch would mean that it's going to be like this. It's going up faster. Okay, a vertical compression, I can't do that with my arms, but it would be like this, wider, a wider V. Okay. And then if A is 1, no shrink. It's just the regular parent function. So if we do not have an A there, remember if there's no A there, if it's just this, where there's nothing in front of this, whether this is a radical or parentheses or whatever, the A is 1. That means that the graph is going to look just like our parent graph. It's just maybe going to be shifted one way or the other, or up and down. Okay? Thumbs up, thumbs down. Good with what A it is? Okay. So now we're going to start to apply this stuff. Okay, so this is where I think for some of us it's going to be really important to kind of go through a thought procedure here, okay? Instead of trying to look at all of it and attack all of it and do all of it at the same time, do one thing at a time. So first, hey, what shape is this going to be? So go back to our parent functions. We've got an exponent right here. So this is going to be a U shape, okay? What kind of graph is it going to be? What's the name of that? Okay, so we know it's a quadratic. Okay, the question doesn't necessarily ask for that, but I think that it's good to know that and write it down. Okay, now, is it going to be reflected in any way? Do we have a negative?
Yeah.
It says x minus 1, but remember this minus 1 is actually our h. Okay? The negative would we be looking here and here. Do we have a negative there? Nope, so we're not going to have any sort of reflection. It's not going to be reflected across the x-axis or the y-axis. Okay? Now let's look at our h value. See how we're kind of going this in just like a step-by-step manner? Okay, so our h, we look inside. Our h is negative 1. Okay, so what does that mean?
Right one.
It's going to go to the right one. Okay, so it's shifted right 1. Okay, and then we go to our k. What's our k, Savannah? 2. Positive 2, so it's up 2. Okay, so now what we're going to do is we're going to graph the parent graph and this new graph, and we're going to talk about how they're related. Okay, so I'm going to put my little coordinate plane here. My parent function I'm going to do in blue, which is just going to be just like that. Just our U shape, because we know it's a quadratic. Okay, now this new one, I know that it's not going to be stretched. I know it's not going to be compressed, so it should be about the same shape. I'm going to do my best to make it the same. I have the benefit on the iPad of being able to like copy and paste, right? I know you can't do that on your notebook. But we need to go right 1, up 2. So I'm going to go to the right 1, and then up 2. 1, 2. And I know my vertex is going to be right there. That's what we're actually moving is the vertex of the graph. Okay? So now I'm going to take this line, and we're going to duplicate it. I'm going to make it red. And we're going to move it. So there, right there, it's on our parent graph, right? So we're going to go right 1, and now we're going to go up 2. So right there is where we're going to place that new graph. Okay? So this part of the question where it says describe how f of x and g of x are related, we just did that right here. Okay? We said that it's translated right 1, up 2. Okay? Now let's do our domain. The domain of this graph. So domain, is that my x values or my y values? It's my x values. Okay, so does this graph have any walls that are keeping it from going out and out and out and out in both positive and negative directions? Nope. So our domain is going to be negative infinity to infinity. Oh, that was a bad one. How about our range? Okay, so range, we're talking about ceiling and floor, right? So I always like to start with the floor because we want to think like bottom up. So Ben said 2. Why is it 2? Yeah, because there's like a floor right here that's keeping this graph from going below that, right? So it's 2, but I should have a bracket, to infinity, positive infinity, because it keeps going up. Why did we use a bracket there?
Because it's stopped right there.
Yeah, it's at 2. 2 could be one of our y values. Okay, really quick. I know we're close to time here. All right, I want you to tell me what shape this is going to be and how it's going to be moved. We're probably not going to have time to graph it. Okay, take 1 minute. What shape is it going to be? How is it going to be translated? Is it going to be reflected? Is it going to be stretched? Is it going to be moved left or right or up or down? Okay, go. Okay, what's the first thing? We notice this guy right here. What's that mean? Reflected across what? Yep, so reflected across x-axis. Great. Okay, next thing. Look at our h value. It says plus 3, right? So what does that mean? Left or right? Left 3. Left 3, and then our k value is minus 5, so that means down 5. What shape is this going to be? A V. Okay, so our absolute value, our parent function, would be this guy right here. Okay, our new graph, I'm going to go left 3, 1, 2, 3, up 5, 1, 2, 3, 4, 5. I run out of space on my, oh, it's down 5. Right? And it's also reflected, so I really run out of space on my coordinate plane, but it would be there. That's what it would look like. All right. This one, the domain
Yeah, 11. Oh, 12. This is 12.
would be negative infinity, infinity. The range is going to be negative infinity to negative 5 with a bracket.